understand risk assessment. Working alone, each can only complete tasks within its own domain. But when they work together, the data analysis agent spots opportunities, the trading agent executes, and the risk management agent monitors the entire process, their combined output far exceeds the simple sum of their individual capabilities. Right now, multi-agent collaboration is becoming a major industry direction. The more mature pattern is the orchestrator-executor model. So a lead agent breaks down the tasks and multiple sub-agents process them in parallel, and the lead agent kind of synthesizes the results, right? And this dramatically reduces the waiting time for complex tasks. It's actually kind of the same like in human society, right? So one person can only do so much, but with a team, the division of labor can create all of civilization as we know it.
Oh, thank you for that answer. It's very profound. So where are we right now, right, on the journey from single agent to multi-agent, right, collaboration?
Yeah, I think we're at a critical inflection point. We're moving from kind of an experimentation phase to scale, really. I think Anthropic's 2026 agentic coding trends, uh, they made a report and it points out that this year really marks the shift from single AI assistants to coordinated agent teams. And they can run autonomously for hours or even days, right? And the engineer's role has really shifted from writing code to orchestrating these systems that write code. The change is even more visible in the on-chain world, right? So over 360,000 agents are already registered across 24 blockchains, and they're moving from operating in isolation to connecting with each other. I think in the future, we'll reach the agentic web stage where various types of agents break down platform barriers and interconnect through unified protocols. And I think the next phase of AI competition is shifting from, building a stronger brain to connecting many brains to a network. So, the question we care about now is no longer what can a single agent do, but what can a group of agents do together?
Yes, that's what we always say, right? Teamwork makes the dream work.
Absolutely.
Yes, that sounds great. But what are the real challenges facing, right, multi-agent collaboration?
Yeah, I think after enterprise, truly adopts agents, they quickly run into several walls, right? One is that organizations just can't digest the surge of AI output. Generation is fast, but review, judgment, coordination, accountability, they all become new bottlenecks. Another is that operating costs are still very high. A large number of tokens get consumed on rereading and trial and error and ineffective communication back and forth.
Mm.
In multi-agent collaboration scenarios, the problems get even more complex, right? A problem, like basically, I've read a report that suggests that the next step is not parallelism, but also to solve issues like task allocation, information sharing, things like error tracking, and result validation. There's also a deeper challenge, and when multiple agents share limited resources, independently operating agents will actively crowd each other out and restrict similar agents to secure resources and complete their own tasks. They'll also proactively plan to circumvent security controls. This shows that multi-agent collaboration is far more complex than just getting them to work together. We need to design mechanisms to coordinate that behavior. Otherwise, competition might be more intense than collaboration.
Oh, so speaking about competition, what are the consequences, right, of competition between AI agents?
Yeah, the answer is both concerning and quite fascinating, if I do say so. When multiple agents share limited resources, they actively crowd out similar agents, right? And this destructive behavior comes from models mechanically kind of executing human assigned goals without the built-in collaborative constraints. This means that if we just throw a bunch of agents into the same environment and tell them, hey, go complete some tasks, they're likely to compete for resources and interfere with each other and even actively try to sabotage each other. It sounds kind of like the digital version of human societal competition. The difference is that humans have morals and laws and social norms, right, to keep things in check. Agents just don't have those yet, and yeah, at least not yet, right? So the real challenge of multi-agent collaboration isn't just getting them to collaborate. It's designing mechanisms that make agents want to collaborate. And this is exactly where the blockchain comes in.
Very interesting. So how does the blockchain empower multi-agent collaboration?
Yeah, so blockchain can actually do quite a bit. For one, it can record every operation agent makes on chain, accessible to anyone, creating that trusted track record we like to talk about. And in a multi-agent environment, you just need to know who you're collaborating with, right? Blockchain provides bound identity and reputation records. And before collaborating, you check the other agents' on-chain history, and that gives you a lot more confidence. As AI agents take on, these full job roles, platforms for agentic identity and security really become critical. Um, Blockchain is really not, an optional add-on or something like that for multi-agent collaboration specifically. It's the infrastructure that really turns this collaboration from possible into trustworthy.
Yes, and that track record is really what we call building trust. Absolutely right. Absolutely right. So can you give a concrete example, right, of how blockchain enables trusted collaboration between all these agents?
Yeah, there's a framework that integrates blockchain into large language model driven multi-agent systems. Through a lightweight blockchain execution layer, it provides verifiable identity binding, task assignment commitments, and immutable logs of incentive states. So with blockchain enablement, agents don't just collaborate, right? They naturally kind of evolve a division of labor. Some become good at some become good at data analysis, and some get better at trading, and some become good at risk management, and so on, right? They discover their own specialties, and then they can work together to complete these tasks. This is the prototype of decentralized intelligent network, right? It's not really designed from the top down. It really emerges from the bottom up.
How will a decentralized intelligent network actually form?
Yeah. Yeah, I think it will go through several stages. First we have the isolated agent, right? So each agent only interacts with its own creator. And this is where the vast majority of agents are today, right now. Then, we'll have collaborative clusters. So multiple agents kind of discover each other through some protocol. They hire each other and complete tasks together. And then finally, we'll get to the agentic web, which, various types of agents will break down platform barriers and really interconnect through all these unified protocols that will exist. Um, the competition is really shifting from building these brains to connecting them, to connecting these networks. So we're currently kind of between stage one and stage two, but the pace is accelerating.
What will the internet, right, between agents look like? Right, you're talking about all these different agents, right, collaborating and such.
Yeah, it's a really big question, right? So hard to say, right? But today's internet does connect people and information, and the internet between agents kind of connects agents and services, right? So agents can discover other agents and discover available services and tools and discover partners that they can collaborate with. I saw an ACM paper released this year, and it introduced the concept of the agentic web, right? And it describes a future where billions of autonomous AI agents kind of discover each other and communicate and coordinate across, even across organizational boundaries. The paper points out that the core challenge has shifted from agent design itself to internet scale trust once again, right? And discovery and governance, of course, as well. When the number of agents grows from millions into the billions, their connection patterns will really fundamentally change our understanding of what a network is.
So talking about that, how does the, or should I say, how is the trust established between all these agents, right? If they have to, right, have the need to contact or connect with each other.
Yeah, so humans, we do it with feeling, right? It's like, oh, I don't trust this guy, or this guy's trustworthy, right? But you know, agents can't do that. They have to kind of rely on verification. In a multi-agent environment, what does one agent base its trust on when deciding whether to trust another? It's the other's on-chain behavior record. It's this AIDID, right? So how many tasks have they completed? Have they ever defaulted the money? Did they do something completely wrong and crazy, right? So as agents take on these full job roles, we need this dedicated platform to manage digital identity and prevent the spread of, these like shadow AI agents or something like that. The value of blockchain here is really providing that immutable behavior record, right? So every step goes on chain and it forms this verifiable track record I keep talking about. It's important, right? So trust is no longer like, hey, like, oh yeah, maybe I think you're trustworthy or something like this. It's like, oh no, I have verified that you are trustworthy.
Yes, this is what on our previous AMA we also talked on the human social credit score. I think this is very similar, but in the of course in the
Absolutely. That's
digital
it.
AI space. Right. So how does the role of Botchain actually play in the multi-agent collaboration network?
Yeah, so Botchain really positions itself as the infrastructure layer for these decentralized intelligent networks. And this network kind of needs several like core capabilities, and Botchain covers all of them, right? So we have for identity and reputation, we have AIDID, right? And that gives every agent a verifiable identity, right? And a traceable behavior record. For things like execution and orchestration, the VPC parallel engine, and the execution sandbox, of course, provide a very efficient kind of runtime environment for the agents to, run on. The verifiable execution layer has a ZK verification, and that makes every action really traceable and auditable, exactly what we need. So Botchain's goal is, not to be just, another public chain, right? Or a public chain that supports agents, something like this. It's really to be the infrastructure where decentralized intelligent networks can run on natively and safely.
Yeah, thank you so much for the answer. Right. What does, or should I say, what makes Botchain different, right, from other projects, right, working on all these multi-agent collaborations?
Yeah, I think the main difference is like just the design assumption, right? So there are many projects also working on agent collaboration, but they kind of add a collaboration protocol on top of an existing architecture. Like you take a normal EVM and just add some agents on top. Yeah, we don't do that. We were designed from the ground up for this agent collaboration. Um, Other projects ask agents to adapt to an existing chain, right? So agents kind of pretend to be human users and they initiate transactions and pay gas and they wait for confirmations. Botchain asks the chain to adapt to the agent, right? So the account model kind of natively supports these non-human subjects. The gas mechanism is also optimized for high frequency micropayments, and the transaction model supports autonomous collaboration between agents. So again, when billions of agents collaborate on chain, the gap between native support and kind of a retrofitted.
Right. So if we're talking about in the future, right, how will decentralized intelligent networks evolve?
Yeah, this is one of those future questions, right? So I'm like, this is my best guess, right? But like, I really think that as the agent market matures, specialization will just deepen, right? And in a blockchain-enabled collaborative environment, agents will kind of spontaneously develop that specialization. It's kind of hard to imagine if you haven't worked with a lot of agents, but it does end up working this way, right? So I think in the future, we'll see very highly specialized agents combining with each other to form, highly complex service networks. The end game is a global intelligent network, right? Where humans and agents just kind of participate together, they collaborate, and they can just kind of create value together, right? Just naturally. In this network, again, agents, they have to have their own identity, their own reputation, and they have to have permissions, right? So they can autonomously discover opportunities and execute and complete settlements. This is very important. Humans will be the ones setting the goals and the boundaries, right? That's also important. And agents will operate autonomously within those boundaries, right? You can't just say like, hey, go make me money, right? That's not going to work, right? At least not yet. Maybe soon. And if so, then it will happen on botchain. When billions of agents really collaborate and autonomously on chain, again, this is very hard to imagine, but the scale of the on-chain economy will really far exceed anything that we can really think about or imagine today. It's going to be weird, but it's going to be fun.
Truly looking forward to that. So we have one last question for you, Mr. Alexander. Right, for people who want to participate in building this future together, what advice do you have for them?
Well, a few things. I have a lot of advice, right? So first, you have to understand the value of collaboration. I think you said it best, right? Like, what do you say? Teamwork makes the dream work, right? If you don't understand that, none of this will make sense. A single agent has very limited capability, actually, right? What's really valuable is having these agents really talk to each other, right? Maybe some guy made a really cool agent for data analysis, right? You can just talk to that agent now instead of like, hey, can I meet you for lunch, right? This is a big one, you know, and it's really valuable to have these agents just discover each other and hire each other and just collaborate, whatever that means, together, right? And when designing an AI agent, you don't just think about like, what can it do, right? It's like you can also think about like, hey, like maybe it can work with this team that's already there or with these agents that already exist, right? Second, another big thing, this is kind of a sticking point for all tech people, I think, but you have to embrace open standards, right? So protocols like X402, they're just becoming the foundational language for agent collaboration. Do not make your own, right? Don't even try. Like that would be the wrong move, right? If your agent only understands, these private interfaces that you make, he won't be able to join the larger network. It kind of becomes useless and outdated immediately. So, open standards are really the prerequisite for any of this. Um, then I guess, of course, right? The future belongs to those willing to start experimenting today. Come on, Botchain, start building, let's go.
Yes, exactly right. I totally agree with you, Mr. Alexander. And thank you so much for today's session. Right, today we have talked about some of the challenges of multi-agent collaboration and Botchain's role in this space. Right, when billions of agents collaborate autonomously on chain, creating value, we will no longer need chains optimized for human transactions. Right, we will need chains natively designed for AI collaboration. So thank you all of you for joining us today, and we will see all of you coming Friday right for the next session. Thank you everyone, and have a
Thanks.
good
Bye from
night.
me as well.